this video, what I'm going to go through is how to do a titration and also the calculations that are involved in a common titration. The one that I'm going to do is between sodium hydroxide and acetic acid and vinegar. Safety is super important, so make sure that you have your hair pulled back, you have goggles on. If you're required to wear gloves, that you put those on at this point before you start. If you don't wear gloves, make sure that if you get an acid or a base on your skin that you go wash it in the sink with copious amounts of water. Last, you want to make sure that if you have jewelry or anything that's dangling, that that's removed before you get started. Before I show you how to do a titration, let's go through a few things first. Number one, if you cleaned and filled your burette using a funnel, make sure you remove that and put that aside. In the burette goes the standard solution, or the one you're standardizing. It's called the Titrant. For mine, it's sodium hydroxide that I know the concentration of. In the Erlenmeyer flask, it goes the solution you're testing or the solid you're testing. For mine, I'm going to try to find the concentration of acetic acid and vinegar. I would measure the volume of that vinegar before I start, put it into the flask. I could use a graduated cylinder that's really accurate, or a graduated pipette to measure the volume of my vinegar. Or you could have used a balance to measure a solid, maybe a solid acid. That would go in the Erlenmeyer flask, and typically you'll even add some water. The next thing is to add an indicator that's appropriate for your titration. For mine, I have a strong base, sodium hydroxide, with a weak acid, vinegar or acetic acid, and then phenolphthalein is the appropriate indicator for this titration. Last but not least, take your white paper, put it behind your burette, read the volume at eye level, record it in your data table as your initial volume. Make sure it's got 2 decimal places and then milliliters as a unit. Once you've done that, you are ready to go. When you first start your titration, make sure that you hold maybe the burette with one hand and put your other hand on the stopcock. You'll turn it to the parallel position, and the solution that is the standard or the titrant is going to be coming out through the tip. Add a little bit and stop because you don't know where the endpoint is. You'll see a flash of pink color, and then when you stir it, that'll go away. Try to avoid hitting the tip of the burette. Add a little bit more. And if you're going to do your first titration slowly, you won't want to go too quickly because you won't know where the end point is the first time. So you want to add a little bit, swirl it, and if you have a lab partner, your lab partner can swirl the Erlenmeyer flask while you are adding the base, or in this case the titrant. And you're going to continue this process until you start to see that pink color, in this case with vinegar, with phenolphthalein as your indicator, persist for a little bit longer. So once you start to see that pink color persist, you'll want to slow down. Another technique that helps when you get closer to the end point is to do a 180-degree turn on the stopcock and stop and swirl it so that you can see that that pink color is persisting longer. This will allow you to add in very small amounts of solution at a time instead of just leaving that stopcock completely open like that and maybe possibly missing the end point. As you're running your titration and you're putting more of your solution that you know the concentration of, the titrant, into the solution that you do not know the concentration of or what the identity is, the analate, make sure that you rinse down the inside of this Erlenmeyer flask with distilled water. As long as you've measured the volume of your unknown or the mass, you should be able to add distilled water anytime during this titration. Once you start to get really close to the endpoint, and again you'll see that by just a small amount of color persisting a lot longer, is to, instead of doing a 180, to try to allow there just to be one drop coming through the burette tip. So you'll take, and you'll usually want to hold with one hand, very slowly turn that stopcock so that you are only allowing out one drop. So again, when you want to have just one drop, you have to very carefully hold the burette with one hand, turn very slowly the stopcock with the other, so that a drop forms on the end of the burette tip like that, If you're able to suspend a drop off of that burette tip, another technique is to take your distilled water bottle and wash that drop down, and you can see that color persisting again and then going away. You know you're getting close to the end of the titration when this pink color persists longer and longer. Once that pink color persists longer, you will want to again try to add only a drop at a time. We are very close to the end of this titration. That's one drop that went in and another drop I'm going to add in through the tip of the burette. You can even touch the side like that. You'll swirl it and you can really see how long that pink color is persisting. So again, we want to go very slow at the end of the titration so that we don't miss the endpoint with the indicator. This is where the amount of base and acid are equal in my titration. So my moles of acid equal my moles of base due to the indicator showing a pink color at this point is telling me I'm reaching what's called the endpoint via the indicator, but the equivalence point based off of moles. So I believe I'm one drop away. So let me see if I can do this. There it goes. And it looks like there is one more on the tip. This should be the endpoint. There's that bright pink color that's persisting. Once that pink color persists for 10 seconds or more, your titration is over. You can see that my bright pink actually turned into a light pink upon standing. That's typical. Within 30 seconds to a minute, a lot of times it'll dim. This is a great endpoint for this titration between vinegar, sodium hydroxide, using phenolphthalein as the indicator. So the last step before you start to clean up is to take a piece of white paper, put it behind that burette, and read the burette at eye level and record that volume in your data table with 2 decimal places and milliliters as the unit. 2 decimal places, for example, means maybe I would record 35.45 milliliters in my data table as my final volume. All right, on to the titration calculation portion of this video. What I did was I tried to find the molarity of acetic acid and vinegar by using that standardized 0.50 molar sodium hydroxide solution. Acetic acid can be written as HC2H3O2. That's the acetate ion right there. Or you could write it as an organic acid as CH3COOH. Next, this is the balanced equation showing that I reacted sodium hydroxide in solution with acetic acid in solution, that's the vinegar, and I produced sodium acetate solution and water molecules as liquid. I like to write water as HOH because you can see these hydroxides reacting with the hydrogens to produce that as a product. I again knew my molarity of my standardized sodium hydroxide solution, and the goal is to find the molarity of acetic acid and vinegar. So here's my data. I ran 2 more trials. You might have to do that also. I kept my volume of acetic acid or vinegar the same, exactly to 2 decimal places. I used a graduated pipette. Then I have an initial and final volume for each one of my trials. So here are the mathematical steps you're going to need to do to solve for the molarity of vinegar that you'd put in each one of these trials. Okay, so step 1 is to find the volume of sodium hydroxide that you used. So what you're going to need to do is look back at your data table and write down these 2 volumes. I had 35.45 milliliters total, and then I started at 0.60 milliliters. So you need to subtract these 2 numbers, and I would just use a calculator. 35.45 minus 0.6, which is 34.85. All right, so that's step 1. Next step is to calculate the volume, but in liters. So 34.85 is in milliliters, and I'll tell you why we need it in liters in just a second. There's 1,000 milliliters in 1 liter, so put 1,000 in the denominator so these cancel, and then you'll get, so if you take this, and if you need to, you can divide it by 1,000 or move the decimal place, so 0.03485, and that's liters. Next, we need to find the moles of sodium hydroxide that we used. So the next step is going to be taking that volume in liters, 0.03485, and then using the standardized molarity of 1 liter was 0.50 moles of sodium hydroxide. So that was my standardized solution that went into the burette. That gives me this many moles, 0.50 0.0174 moles. So how did I get that? I multiplied this liter volume by 0.5, so 0.074, and then I just didn't keep more than 3 sig figs, so I'm just going to keep it like that, and that's moles of NaOH. Next step is to find the moles of acetic acid that you had present, that you neutralized with that reaction. So you're going to start with 0.0174 moles of NaOH. And then, because we did a chemical reaction, we have to use what's called a mole ratio. The mole ratio comes off the balanced equation. So right here, we're kind of lucky. They're all 1, so they're all 1 mole of each. So for every 1 mole of sodium hydroxide, I'm going to neutralize 1 mole of acetic acid. So I'm going to take those, and those are the mole amounts. I always switch colors. There's 1 mole to 1 mole. There's my mole ratio of the sodium hydroxide to the acetic acid, so moles of NaOH converted to moles of acetic acid. Not every reaction has 1-to-1. We just kind of got lucky this time, so 0.0174 moles of acetic acid. So they have the same mole amount. That's what I neutralized with my titration. Next step is to take that volume of vinegar and turn that into liters also. So it's very similar to the first step. Right here, actually should I say the second step. So 1,000 milliliters is 1 liter, so we're going to get 0.02000. All those trailing zeros actually I measured with my graduated pipette. And then that's going to be of my vinegar, or that's where the acetic acid is, okay? Next, molarity is defined as moles per liter. So what you can do then is take your moles of acetic acid that you neutralized with that base, C2H3O2, and then just divide it by your volume that you use, 0.2000. And when you divide these two numbers, you will get your molarity. So there's my moles. I just kind of kept it in my calculator. Divide it by 0.02. I'm not going to put the zeros in. I'm just going to do that. And then I got 0.087125. 0.087125. I can't keep all that. Because my standardized solution up here, I only standardized it to 2 decimal places. I can only keep 2 digits. So I can only report that my first run of my titration here had 0.87 molarity, put it in pink here, of vinegar, or acetic acid and vinegar. So there's the first trial. What I'd like you to do is, go back to this table here. You can use my data. So again, my volume initially was 34.85. First thing you're going to want to do is get your volumes in here in the data table, and then run through the 2 calculations to get the molarity. I'm going to just say 1, 2, 3 and pause, and then I'm going to show you the answer. So here's the work and answers for the next 2 trials. You can even line them all up. This time I didn't do step by step. I put it in a long stoichiometric or unit factor method setup. So I got 0.84 and 0.83 with trial 2 and 3. Then I'm going to take an average molarity to get 0.85 as my average of all my trials. And then the next thing, I went onto the internet or looked up in some books what's probably the accepted value for the vinegar acetic acid concentration, and I found 0.83. So then I took my value, subtracted it from the accepted, and then divided by the accepted, which is the definition of percent error. And then I multiplied by 100, and I got a really nice 2.4% error with my titration. So those are the last calculations that you would need. A couple more things though. You might want to rewrite those back in your data table. So you may go back and put in your volumes in here. So 33.45, what was the other one? 33.35, and then put your molarities down here. So for example, like I had 0.87 molar, and then my second run I had 0.84 molar, and so forth, okay? I'm going to go through 2 last things here, 2 terms that I really think you're going to need to be successful with these titrations. One is equivalence point. It's the stoichiometric point where the moles of titrant equal the moles of the analate. In my titration, my acid and base titration, I had equal moles of acid and base, was the sodium hydroxide and acetic acid. The other thing is that, again, a titrant is the standardized solution that usually we put in that burette. Another term is endpoint. Endpoint is actually different. It's when the indicator changes color and it shows you that you've reached the equivalence point. And the indicator is just any chemical that's going to change color to kind of signify that you've reached that.